Now we begin with the 17.4 theme, characteristics of quadratic functions. This is the page 651. The instruction says that you have to use the graph calculator, but you don't need it. Remember, a quadratic function is degree 2, then answer the page 651. Let's continue with example 1. Identify quadratic functions. Okay, example 1. Now, remember that you need to compare a complete quadratic function. It's y equal ax squared plus bx plus c. Okay? Now, in A, we have y equal minus 2x plus 20. Here, A is equal 0, B is minus 2, and B is 20. No, sorry, C is 20. When we have A 0, there is no a quadratic function because we don't have a quadratic member. Okay. B, we have y plus 3x squared equal minus 4. Then we put it in standard form. We put it y equal minus 3x squared minus 4. Then here a is equal minus 3, b is 0, and c is minus 4. Then we have a3, then it's a quadratic function. And then c, we have minus y plus 2 plus 4x squared equal 4x. Now we want to put it in the standard form. Minus y equal minus 4x squared minus 2 plus 4x. Then we change the sign. Then it's going to be y equal 4x squared minus 4x plus 2. Now we have the quadratic term. Then that is a quadratic equation. We're going to erase. Now, you're going to read carefully the green rectangle on page 653, minimum and maximum values. This is example 2. Okay, determine the maximum or minimum value of each quadratic function. We have in A this graph. Here is 5. Here is 1. Then we have a maximum value and 5. You check. And the parabola open, downward. Okay? And example B, we have this graph. It's minus 2, and here is minus 5. Now, the parabola open, upwards, and minus 5 is the minimum value. If you check, okay. Now, C, we have the equation. Y equal 2x plus 1 minus, sorry, this is square, minus 6. Now, the vertex here, if you see, is going to be minus 1, comma, minus 6. The A is greater than 0, then is upward. Then we obtain the minimum in minus 6. Now we have D, the equation y equal minus 3 x minus 4 squared plus 5. Then the A is less than 0, then it's downward, and we have a maximum value in 5. Oh, remember the vertex is going to be 4, 5. Then answer the page 654. I'm going to erase. Then, the zeros of a function is a value of x that makes the value of the function 0. The zeros of the function are the x-intercepts of the graph. The quadratic functions maybe have 1, 2, or known zeros. Example 3. Find the zeros of each quadratic function and check your answers. We have A, like y equal x squared minus x minus 2. We do the table to obtain the values in minus 2, minus 1, 0, 1, and 2. We substitute the values here. We obtain minus 2 squared minus 2 minus 2. Here is minus 1 squared minus 1 minus 2. Here is 0 squared minus 0 minus 2. Here is 1 squared minus 1 minus 2 is 2 squared minus 2 minus 2. Here we check, and it's going to be 4 plus 2 minus 2, then it's going to be 4. Here it's 1 squared plus 1 minus 2. We obtain 2 minus 2 is going to be 0. Then the next is going to be 0, 0, then it's going to be minus 2. The next is going to be 1 minus 1 minus 2 is going to be minus 2 because it's cancelled. Okay, here we obtain 4 minus 2 minus 2, we obtain 0. Now we're going to do the graph. We obtain this and this, and minus 2 is 4, and minus 1 means 0, and 0 it's minus 2, and 1 is 2 minus 2, and 2 is going to be 0. Then the graph is going to be like this. Okay, then we check the zeros. This is the 1 0 and this is the other. We obtain here and here. Now we check, we substitute the values, obtain y equal, the value is going to be minus 1, it's going to be minus 1 squared minus 1, sorry, minus minus 1 minus 2. Then y is equal to 1 plus 1 minus 2. This is going to be 2 minus 2. It's equal to 0. Then it check. And the other is going to be 2. Then y is equal to 2 squared minus 2 minus 2. Then y is going to be 4 minus 4. Then y is going to be 0. Then we check the zeros of the function.